We live on a razor's edge of statistical impossibility. Here are 25 cosmic coincidences that made Earth the perfect planet. Number 25. The atmospheric pressure boundary. At sea level, Earth maintains an atmospheric pressure of exactly 1 atmosphere, or 14.7 pounds per square inch. This is not just a random meteorological statistic. It is the precise physical boundary required to keep water in a liquid state across the vast majority of our planet's surface. Think about the mechanics here. The boiling point of water is entirely dictated by the weight of the air pressing down upon it. At 1 atmosphere, water boils at 212 degrees Fahrenheit, a temperature threshold well above our ambient climate. But strip away that density, lower the pressure to something resembling the thin, dying atmosphere of Mars, and the rules of physics change instantly. In a near vacuum, water boils at room temperature. Without the crushing, invisible weight of the sky pushing down on us, the water within our oceans, our rivers, and the very blood running through our veins would flash boil into vapor. Every breath you take is facilitated by a localized pressure system that refuses to let your biological fluids expand into a gas. We are deep ocean creatures surviving at the bottom of an ocean of air. Number 24. The tropopause cold trap. Approximately 9 miles above the Earth's surface lies an invisible thermal ceiling. Meteorologists call it the tropopause. In the lower layers of our atmosphere, the higher you climb, the colder it gets. But at the tropopause, this pattern abruptly flatlines. The temperature plummets to a bone-chilling negative 70 degrees Fahrenheit and locks in place. This extreme, sudden wall of cold creates an impenetrable physical barrier for water vapor. When moisture from the oceans evaporates and rises, it eventually hits this freezing layer. It condenses into ice crystals, becomes heavy, and is forced to fall back down to the surface as rain or snow. Look at the alternative. Without this specific atmospheric anomaly, water vapor would continue to drift upward unhindered into the upper stratosphere. Up there, raw ultraviolet radiation from the sun would violently sever the chemical bonds of the water molecules, splitting them into hydrogen and oxygen. The lightweight hydrogen would bleed out into the vacuum of space forever. Over billions of years, this steady, invisible hemorrhage would have drained every ocean dry. Our entire global water supply is held prisoner by a wall of freezing air suspended high above the clouds. Number 23. The 24-hour rotational velocity. Earth spins on its axis at roughly 1,000 miles per hour at the equator. It completes a full rotation every 24 hours. This exact speed acts as a planetary rotisserie, perfectly distributing the sun's lethal thermal energy across the globe. If our planet rotated significantly slower, taking weeks to complete a single turn, like Mercury or Venus, the mechanics of our climate would collapse. The sun-facing side would be subjected to relentless radiation, driving temperatures into the hundreds of degrees, baking the continents down to cracked dust. The dark side would plunge into a permanent freezing night. The atmospheric clash between these two extremes would spawn eternal, continent-spanning storms. But what if we spun much faster? A day lasting only 4 or 5 hours would drastically amplify the Coriolis effect. The atmosphere would be whipped into a perpetual frenzy. We would experience hypercanes, localized hurricane systems with wind speeds exceeding 1,000 miles per hour. These storms would scour the Earth down to the bedrock, flattening any biological structures trying to grow. Our 24-hour day is a delicate mechanical compromise. We spin just fast enough to avoid being baked alive, and just slow enough to keep the wind from tearing the planet's surface to shreds. Number 22. The near-perfect circular orbit. The path Earth takes around the Sun is not a perfect circle, but it is astonishingly close. Our orbital eccentricity is currently measured at 0.016. That means our distance from the Sun barely fluctuates throughout the year. This geometric precision ensures a remarkably stable influx of solar radiation. When we point our telescopes at exoplanets and other star systems, we frequently find them locked in highly elliptical, oval-shaped orbits. If Earth shared those common cosmic variations, our planet would swing wildly in and out of the habitable zone every single year. At our closest approach, the Sun would loom massive in the sky, delivering enough heat to ignite global firestorms and evaporate surface water. Months later, we would be hurled out into the freezing outer reaches of the system, triggering sudden global ice ages. Complex life cannot gain a foothold when it is forced to adapt to a yearly cycle of being thrown into a furnace and then locked in a freezer. Our existence relies on a smooth, unvarying track that keeps us suspended at the exact same distance from a thermonuclear explosion for billions of years. Number 21. The tidal churning engine. The moon does not just illuminate the night sky. Its gravitational pull physically warps the Earth, dragging trillions of tons of seawater across the globe twice a day. This relentless tidal action is a biological necessity. The constant ebb and flow prevents our seas from becoming stagnant, oxygen-deprived pools. Tides act as a planetary mixing spoon. They force the deep, cold, nutrient-rich waters from the ocean floor up to the surface. This feeds phytoplankton, the absolute foundation of the global food web, and the source of half the oxygen you breathe. Furthermore, the creation of tidal zones provided the critical evolutionary crucible for life to transition from water to terrestrial continents. These dynamic, shifting shores forced aquatic organisms to adapt to temporary dry spells, driving the evolution of lungs and limbs. Without the sweeping drag of the moon's gravity, the deep waters would turn toxic, harboring only primitive anaerobic bacteria. Life did not just passively emerge in a calm puddle. It was aggressively kneaded into existence through perpetual, rhythmic disturbance. Number 20. The absence of hot Jupiters. When astronomers finally began mapping other star systems, they expected to find architectures similar to our own. Small, rocky planets close to the star, gas giants further out. Instead, they discovered a universe filled with planetary wrecking balls. Hot Jupiters are colossal gas giants that orbit astonishingly close to their host stars. They don't start there. They form in the outer system and migrate inward, drawn by gravitational drag. As one of these behemoths spirals toward its sun, its immense gravity disrupts, ejects, or outright pulverizes any smaller, rocky planets in its path. If our solar system possessed a hot Jupiter, Earth would have been annihilated billions of years ago. We would have been swallowed by the gas giant, hurled into the sun, or violently ejected into the freezing void of interstellar space as a rogue planet. We exist in a freakishly tranquil neighborhood. The planetary giants stayed in their lanes. The mere fact that our inner solar system is quiet and untouched by a migrating gravitational monster is a statistical rarity. Number 19. The rhythm of Saturn. The reason we don't have a hot Jupiter destroying our world is due to a delicate gravitational dance known as the grand tack. Billions of years ago, our own Jupiter began that exact deadly migration. It drifted inward toward the sun, plowing through the primordial rocky material. It threatened to clear-cut the inner solar system, completely erasing the orbit where Earth would eventually form. Then, a cosmic break was pulled. Saturn formed just behind it. As Saturn grew, its gravitational pull caught up with Jupiter. The two giants locked into a perfect orbital resonance. Saturn physically pulled Jupiter backward, halting its inward march and dragging it back to the outer solar system, where it resides today. This maneuver spared the inner rocky material. We owe our entire existence to a perfectly timed gravitational tether deployed from 1 billion miles away. If Saturn had formed slightly later, or with slightly less mass, Jupiter would not have stopped. Earth would never have been anything more than scattered, floating dust. Number 18. The perfect late heavy bombardment. Earth was born entirely dry. The immense heat of our planet's formation vaporized any native water, leaving a molten, barren sphere of rock. Our oceans had to be imported. During a chaotic period roughly 4 billion years ago, a massive influx of primordial asteroids and comets from the outer solar system was hurled inward. They pummeled the young Earth. These icy impactors carried the 326 million cubic miles of water that now make up our oceans. The timing of this delivery is staggering. The bombardment was vicious enough to fill our ocean basins, but it stopped just before the water volume could submerge the entire planet. If this chaotic rain of comets had lasted a fraction longer, Earth would have become a water world, a planet covered by a single ocean thousands of miles deep, with no exposed land masses. Without continents, the vital chemical weathering necessary to regulate the carbon cycle and stabilize the climate could never occur. We were aggressively carpet-bombed by space debris, and the onslaught ceased at the exact moment the water level reached the optimal threshold for life. Number 17. Jupiter's gravitational sweeping. While Jupiter nearly destroyed us in its infancy, it now serves as our greatest protector. Sitting at the edge of the inner solar system, it possesses a mass 2.5 times greater than all the other planets combined. This immense gravitational well acts as a cosmic vacuum cleaner. As rogue asteroids and comets drift inward from the Kuiper Belt and the Oort cloud, Jupiter intercepts them. It either absorbs the impacts directly or violently slingshots them out of the solar system entirely. Without Jupiter standing guard, the frequency of extinction-level impacts on Earth would increase exponentially. We wouldn't be dealing with a dinosaur-killing asteroid every 100 million years. We would face planetary sterilization on a regular, predictable basis. Earth is sitting in a cosmic shooting gallery. We survive only because we have an invisible shield taking the vast majority of the hits for us. Our evolution is a direct result of Jupiter reducing the chaos of space down to a manageable trickle. Number 16. Perfect galactic isolation. Look up at the night sky. We see thousands of stars, but in galactic terms, we are sitting in an empty void. Our solar system is located in the Orion Spur, a minor, sparsely populated bridge between two of the Milky Way's major spiral arms. This isolation is crucial. In the dense centers of the galaxy, stars live and die in close proximity. When massive stars reach the end of their lives, they detonate as supernovae, releasing incomprehensible blasts of gamma radiation. If Earth were located in one of these tightly packed neighborhoods, we would be subjected to frequent, sterilizing bursts of radiation from exploding neighbor stars. A supernova within 30 light-years would effortlessly strip away our ozone layer, bathing the surface in lethal cosmic rays and wiping out the biosphere. Our safety is entirely dependent on our loneliness. We are tucked away in the quiet suburbs of the galaxy, deliberately kept far away from the vibrant, violent, stellar cities where entire planetary systems are routinely baked alive. Number 15. The galactic habitable zone. Just as there is a habitable zone around a single star, there is a Goldilocks ring within the galaxy itself. If our solar system had formed too close to the galactic core, we would face the relentless threat of supernovae and the intense gravitational chaos of passing stars. These would regularly rip comets from our Oort cloud and send them crashing into Earth. We would also be bathed in the lethal radiation emitting from the supermassive black hole at the center of the Milky Way. But form too far out on the galactic rim, and you face a different kind of death. The outer edges of the galaxy are deeply impoverished environments. They lack the heavy elements, iron, carbon, silicon, and oxygen, forged in the hearts of older stars. Out there isn't enough raw material to form rocky planets at all, let alone the complex organic chemistry required for biology. We are perfectly situated in a narrow ring, far enough from the core to avoid being irradiated, but close enough to have access to the atomic debris necessary to build flesh and blood. Number 14. The Goldilocks mass. Earth's physical size is a masterpiece of gravitational engineering. We possess just enough mass to hold on to a thin, life-sustaining envelope of gases like oxygen and nitrogen. If Earth were slightly smaller and lighter, like Mars, our gravity would be too weak. The relentless solar wind would have slowly stripped our atmosphere away into the void, leaving a frozen rock. But increase our mass to that of a super-Earth, and the consequences flip. A massive Earth would greedily hold on to the lighter, primordial gases like hydrogen and helium present during its formation. We would have ended up with a crushing, toxic atmosphere thousands of miles thick, resembling a mini Neptune. The atmospheric pressure at the surface would crush bone to dust. No sunlight could ever penetrate the hazy sky. We represent a narrow physical threshold. A little less mass, and we suffocate in a vacuum. A little more mass, and we are crushed under an ocean of toxic gas. Number 13. The subterranean nuclear reactor. Beneath the calm, solid surface we walk upon, the Earth's interior is a raging inferno, reaching temperatures of 10,800 degrees Fahrenheit. This heat isn't just leftover thermal energy from the planet's formation. It is actively generated by a massive, ongoing nuclear reaction. Deep within the mantle and core, radioactive isotopes, primarily uranium-238, thorium-232, and potassium-40, are constantly decaying. This slow, steady nuclear fission generates half of the Earth's internal heat. Without this radioactive decay, our planet's core would have cooled and solidified billions of years ago. Plate tectonics would have seized up. Volcanism would have stopped. The vital magnetic field would have collapsed. Earth would be geologically dead. The stability of the ground beneath your feet and the invisible magnetic shield protecting you from the sun are entirely powered by the continuous, violent deterioration of heavy metals deep underground. We are sustained by the controlled decay of the most lethal elements in the universe. Number 12. The precision of the ozone layer. For the first 2 billion years of Earth's history, life was strictly confined to the oceans. The surface of the planet was a barren wasteland, bombarded continuously by the sun's ultraviolet C radiation. This wavelength of light is so energetic it literally shreds DNA. Terrestrial biology was mathematically impossible. It wasn't until early cyanobacteria spent eons pumping oxygen into the atmosphere that a freak chemical reaction occurred high in the stratosphere. Solar radiation struck these oxygen molecules, splitting and reforming them into O3, or ozone. Today, this layer absorbs 98% of the sun's lethal UVC rays. Look at the sheer fragility of this shield. If you were to take all the ozone spread throughout the upper atmosphere and bring it down to sea level pressure, it would form a layer only 3 millimeters thick, the thickness of 2 pennies. The entire evolutionary history of terrestrial life, every forest, every animal, and all of humanity, is protected from immediate genetic destruction by a microscopic film of unstable gas. Number 11. The axial tilt miracle. As Earth orbits the Sun, it doesn't spin perfectly upright. It leans on a precise 23.5 degree axis. This geometric flaw is the sole reason we have seasons. As we travel our orbit, the tilt causes the northern and southern hemispheres to alternate their exposure to direct sunlight. This constant shifting prevents thermal energy from pooling exclusively at the equator. If Earth had zero tilt, the equator would be a permanent, boiling desert. The poles would expand into massive frozen wastelands covering most of the globe. Life would be confined to narrow twilight bands. Conversely, if the tilt were extreme, say 90 degrees like Uranus, the planet would roll on its side. Entire hemispheres would be subjected to 6 months of blistering, continuous daylight, followed by 6 months of freezing darkness. The climate would be impossibly violent. Our 23.5 degree tilt is the perfect thermal distribution system. It ensures that heat is swept evenly across the latitudes, creating moderate, cyclical changes that force life to adapt without being pushed into absolute, sterilizing extremes. Number 10. The plate tectonics thermostat. Earth is the only known planet in our solar system with a fractured crust. While this mechanism causes devastating earthquakes, it is also the ultimate planetary thermostat. Without it, Earth would succumb to a runaway greenhouse effect. Over millions of years, volcanoes vent massive amounts of carbon dioxide into the atmosphere. This gas traps heat. Rain washes this carbon out of the air, binding it into rocks on the ocean floor. But the cycle is only completed when tectonic plates collide, and one is forced beneath the other into the mantle. This process, subduction, drags billions of tons of carbon back into the Earth's interior, permanently removing it from the atmosphere before it can build up to catastrophic levels. If our crust were a solid, unbroken shell like Venus, the carbon would have nowhere to go. It would accumulate in the atmosphere, trapping solar heat until the oceans boiled away and surface temperatures reached 900 degrees Fahrenheit. Our planet only survives because its skin is broken. We rely on the grinding destruction of the Earth's surface to swallow the gases that would otherwise bake us. Number 9. The density anomaly of water. In the realm of physics and chemistry, a standard rule applies. As substances cool and freeze from a liquid into a solid, their molecules pack closer together, becoming denser and heavier. Water breaks this fundamental rule. As water cools below 39 degrees Fahrenheit, it expands. The molecular structure forms a crystalline lattice that is roughly 9% less dense than liquid water. This is why ice floats. If water behaved like almost every other substance in the universe, ice would be heavier than liquid water. It would sink to the bottom of the oceans and lakes. During the winter, the surface would freeze, sink, and expose new water to the freezing air, which would also freeze and sink. Over time, the entire body of water would freeze solid from the bottom up, exterminating every organism inside. Because ice floats, it forms an insulating barrier on the surface, trapping the geothermal heat below and allowing liquid water and marine life to survive the coldest winters. A localized rebellion against standard thermodynamics by a single molecule is the only reason our oceans still exist. Number 8. The nitrogen-oxygen balance. The air we breathe is a highly reactive cocktail. It is composed of 78% nitrogen and exactly 21% oxygen. This ratio is not arbitrary. It is a razor-thin boundary between suffocation and spontaneous combustion. Oxygen is an intensely volatile gas. It fuels the metabolic fires of every complex organism on Earth. But it is also highly flammable. If the atmospheric oxygen level were to rise just a few points, crossing the 25% threshold, the atmosphere would become a planetary powder keg. Even wet vegetation would ignite instantly from a lightning strike, triggering global firestorms that would burn until the surface was reduced to ash. Conversely, if oxygen levels dipped below 15%, the spark of respiration would fail. Complex animals would instantly begin to suffocate. We are surviving in an atmosphere perfectly diluted by inert nitrogen. Our air is essentially a controlled chemical burn. We inhale just enough poison to live, but not enough to catch fire. Number 7. The abnormally massive moon. When we observe other planets in our solar system, their moons are minuscule specks compared to their host worlds. Mars's moons are tiny captured asteroids. Jupiter's largest moon is massive, but it is only a tiny fraction of Jupiter's immense volume. Earth, however, possesses a satellite that is fully 1/4 of its own size. This size ratio is incredibly rare. It is so anomalously large that some astronomers classify the Earth-Moon system as a binary planetary system. This gigantic companion exerts a gravitational dominance over Earth that no other planet experiences. We need it. The immense mass of the Moon drives the deep oceanic tides, and it provides the sheer gravitational muscle required to keep the Earth's axis locked in place. If our moon were proportionate to the moons of other planets, it would lack the mass to influence us. It would just be a dead rock hanging in the sky. Instead, we are tethered to a gravitational monolith that manipulates the physical mechanics of our world from 250,000 miles away. Number 6. The stabilizing anchor. Our massive moon serves one critical overarching purpose. It is our gravitational anchor. While the Earth spins, the gravitational pulls of the Sun, Jupiter, and the other planets are constantly tugging at our equatorial bulge, trying to pull us off balance. Without the massive gravitational presence of the Moon acting as a counterbalance, Earth's axial tilt would not remain stable. It would undergo chaotic, wild fluctuations. Mathematical models suggest that without the Moon, Earth's tilt could swing anywhere from 0 degrees to 85 degrees over time. At an 85-degree tilt, the Earth would literally be knocked onto its side. The poles would point directly at the Sun, subjected to 6 months of blistering heat, while the equator plunged into deep freezes. The climate would be a chaotic, violently shifting nightmare, incapable of sustaining long-term evolutionary progress. The steady, predictable climate we enjoy is entirely outsourced to an alien rock hovering in space. Without its invisible grip, our planet would drunkenly tumble through the void. Number 5. the quietness that rejects extinction. The vast majority of stars in our universe, roughly 75%, are red dwarfs. Because they are so common, scientists initially believed they would be the most likely places to find habitable planets. But red dwarfs are inherently violent. They frequently erupt with colossal superflares, bursts of magnetic energy and stellar radiation hundreds of times more powerful than anything our sun produces. Any planet orbiting close enough to a red dwarf to have liquid water would be routinely blasted by these flares, completely stripping away its atmosphere and sterilizing the surface. Our sun, however, is chillingly quiet. In the 4.5 billion years it has existed, it has burned with a smooth, steady output. It has never produced a megaflare strong enough to boil our oceans or strip our ozone. This level of prolonged tranquility is remarkably unusual for an active thermonuclear reactor. The silence of the sun is what allowed fragile, carbon-based life to crawl out of the mud without being periodically erased by apocalyptic bursts of stellar fire. Number 4. The rarity of a G-type star. Our sun is a G-type main sequence star, commonly known as a yellow dwarf. It represents a massive cosmic anomaly. Only about 7% of all stars in the universe fit this classification. We are orbiting a profound rarity, and this specific type is the absolute sweet spot for biological evolution. Massive, blue O-type and B-type stars burn incredibly hot and bright, but they consume their nuclear fuel in a matter of millions of years, exploding as supernovae long before complex life has the time to evolve. Conversely, the smaller, more common red dwarfs burn for trillions of years, but are too volatile and dim, requiring planets to orbit dangerously close. Our rare G-type sun hits the exact center of the target. It possesses enough mass to burn warmly and steadily, and enough fuel to last for 10 billion years. It provides the vast, unbroken stretches of deep time required for single-celled organisms to slowly evolve into sentient beings. Number 3. The fatal collision with Theia. None of this, the stabilizing moon, the thick atmosphere, the magnetic shield, would exist without a primordial apocalypse. Roughly 4.5 billion years ago, a Mars-sized protoplanet named Theia was on a collision course with a young, developing Earth. The two planets collided in a catastrophic, glancing blow. The sheer kinetic energy of the impact liquefied the surfaces of both worlds and vaporized their mantles. Theia was utterly destroyed. But the heavy, metallic iron core of Theia sank into the Earth, merging with our own core. This dramatically increased Earth's mass and density. Meanwhile, the colossal cloud of vaporized rock and debris ejected from the impact spiraled into orbit and slowly coalesced to form our abnormally large moon. We are the survivors of a planetary assassination. If Theia had missed, Earth would have remained a smaller, weaker planet. We would have no moon to stabilize our axis, and our iron core would be too small to generate a strong magnetic field. The most destructive event in the history of our world is precisely what upgraded our planet into a fortress. Number 2. The magnetic shield. Deep within the Earth, the massive, spinning core of liquid iron and nickel acts as a colossal geodynamo. As it churns, it generates an invisible, vast magnetic field that extends thousands of miles out into space. This magnetosphere is our final line of defense against the cosmos. The sun is constantly blasting us with solar wind, a supersonic stream of highly charged, lethal plasma particles. If these particles hit our atmosphere directly, they would transfer their kinetic energy to the gas molecules, gradually stripping them away into the vacuum of space. This is exactly what happened to Mars. It once had oceans and a thick atmosphere, but its core cooled, its magnetic field died, and the solar wind slowly flayed the planet alive. Our invisible magnetic shield deflects this lethal solar radiation, bending the plasma around the Earth and allowing it to harmlessly slide off into deep space. Our breathable air and liquid oceans are protected only by an invisible ghost of magnetism, generated by a swirling ball of liquid metal thousands of miles underground. Number 1. the Goldilocks zone. All of these parameters, the magnetic shield, the tectonic thermostat, the massive moon, the ozone layer, mean absolutely nothing without the ultimate planetary lottery ticket. Earth is located exactly 93 million miles from the Sun. This specific distance is the circumstellar habitable zone. It is the narrow orbital band where the solar radiation is perfectly balanced to allow water to exist as a liquid. If we were a mere 5% closer to the Sun, the increased heat would trigger a runaway greenhouse effect. The oceans would evaporate, trapping even more heat, rapidly turning Earth into a pressurized, boiling hellscape like Venus. If we were just 15% further away, the decreased solar energy would cause the oceans to freeze solid. The white ice would reflect the remaining sunlight, plunging the planet into a permanent, unrecoverable deep freeze like Mars. Our entire existence is predicated on a cosmic tightrope walk. We are hurling through the absolute zero of space at 67,000 miles per hour, suspended at the exact mathematical coordinate required to keep water wet, the air breathable, and the fires of evolution burning. If you want to see more videos like this, click the video on your screen right now.